There you go.
I guess the new UI is better. It's less busy, but you have to know what all the icons are.
Yeah, right.
Just give it 1 or 2 more minutes.
Yeah.
We have a pretty light agenda, and people only requested 15 minutes, I gave them 25. So
Yep.
we should be able to end early.
Well, making up for last time where we were a little pressed, so.
Were we pressed last time?
Yeah, well, I requested more time for the meeting this time for that reason.
Everything's a blur. I don't even remember the last meeting.
Yeah, well, I got some terrible infection like that evening or something. So,
Really?
Yeah, and I was sick the rest of the IETF.
Oh man, that stinks.
So I don't remember the rest of the week, but I remember.
Just going to give it 1 more minute in case anyone else needs to join on remotely. We have a light agenda today, so we'll hopefully be able to finish early. Just go ahead.
Yeah.
Okay, let's go ahead and get started. Welcome everyone to Brisbane, Australia. We're here at IETF 119 for the MLCODEC workgroup session, machine learning for audio coding. First of all, note well the IETF IPR policy. Please review that in detail, but a short summary is that as a participant in IETF activities, which includes this meeting, activities on the list, that you should declare any IPR that you're aware of that applies to any of the materials that are discussed in the meeting or that you contribute. But please read the BCPs there for the full details. And also note the code of conduct. Please treat all of the participants professionally. And finally, the meeting tips. If you're in the room, you can scan that QR code that's up on the screen, or you can click on the on-site tool in the meeting agenda. That'll take you to the MeetEcho client for in-room participation. You'll use that client to join the microphone queues, and that'll all automatically sign the blue sheets for your attendance. If you're, and also for in-room participants, please keep your video and audio off the entire time. You'll be captured on video and audio if you go to the mic. For remote participants, please use the full client, and that's the full video icon in the meeting agenda. And again, also leave your audio and video off until you're actually speaking. It's your turn at the queue. So first of all, we need to find note takers for the session. It'll be really easy. Thank you very much. And just enter the Etherpad from the link in the agenda. Take notes directly there. Sorry, Jonathan, couldn't hear.
It's not called Etherpad anymore. It's called
The notes.ietf.org. Let's not give it a name. Let's just give it a URL. And I think the chairs can monitor the chat. Okay, so on the agenda, there's 3 items, each of which correspond to one of our chartered work items. So there's first the Opus extension mechanism. Tim's going to talk about that. That's a work group draft. There's the deep redundancy. Jean-Marc is going to cover that, and that's still an individual draft. And then finally, the speech coding enhancements, and Jan is going to cover that. Again, that's also an individual draft. Is there anything that people would like to bash on the agenda? Okay, hearing nothing. Tim, you're up. And I will share the slides for you, if that's what you
Okay.
prefer.
Yeah, make it easy. All right, so I'm Tim Terryberry. I'm going to talk about the Opus extension draft. Next slide. So there's been no changes to the draft since the last meeting. So 0.1 is still the current version. Next slide. One thing I do want to talk about at this meeting, however, is the extension ID numbering scheme, which is something that we need to sort out before this can be published. So basically, the question is how should we number the 0 or 1 byte extensions? So if we use one ID for both the L equals 0 and L equals 1 version, so that's one with no payload and one with a 1 byte payload, then we have to allocate them in pairs in the IANA registry, and we can't signal support independently in SDP, which, if you have an extension that always wants 1 byte or an extension that always wants 0 bytes, means you're going to be wasting one of the code points. And a question that was raised briefly after the last meeting is, should they really be 0 or 1 byte extensions, or should they be 1 or 2 bytes or more? Some question of how actually useful a 0 byte extension is, even though we already have one in the separator extension. So I have thrown together a straw man proposal. If you go to the next slide. And this is just sort of to get people's opinions, but here is one that we could go about solving this. And I think this is roughly something that Jean-Marc mentioned in the list some time ago. Basically, we would split the extension ID space into short and long extensions. So the first column in that table there is the code point, so the actual byte value that will be signaled. The second column is the IDs, and then the third column is the length. So we have to specify the length because people need to know how to skip unknown extensions. And so for extension bytes 4 to 63, these are the short extensions, and I'm proposing that we set the length to be the bottom 2 bits of that code point. So any length between 0 and 3. And then for the range 64 to 255, those are the long extensions. So there, the bottom bit tells you whether you either use the rest of the packet or whether you explicitly code a length. And basically, the reason that these are 2 separate cases is because we want to be able to allocate the short extensions, potentially in groups, right? Like an extension might want to have several different possible lengths and use those bottom bits to select which length, but all being used for the same extension. Meanwhile, for the long extensions, we always want to allocate in pairs. And the reason is because if you don't have the option to explicitly code a length, then, for example, if you only had the code point with an even code word so that it would be the signaling you would use the rest of the packet, then you can only code one of those in any given packet. So to allow implementations to merge multiple extensions in a given packet, or have extensions for multiple frames in a given packet, you want to be able to switch between those 2 encodings. So you always want to have both code points available. All right, next slide. So how do we do this? For the short extensions, as said, they're fixed lengths from 0 to 3 bytes. So the idea is that there would be 1 extension ID per code point. So every different byte value is its own extension ID. That's the A0 to A59. And each extension can register multiple IDs. And the way we would signal this in SDP is that you must include all of the IDs registered for an extension in the extensions equals parameters if you support that extension. And then the extension names actually include all of the code, all of the extension IDs for that extension in the extension name. And then for the long extensions, there's 1 ID per extension, and it covers both the even and the odd code point, and that works exactly like you'd expect. I see Jonathan Lennox in the queue.
Yeah, I don't understand what this A0 to A59 means.
Basically, they're just 2 extension ID numbering spaces.
Okay.
So A0 to A59 corresponds to code points 4 to 63.
Oh, I
and
see.
B0 to B95 corresponds to code points 64 to 255.
I think it'd probably be clearer to just call them by the numbers rather than this A0, B0 thing. I think that's, just call them 3 to 64 or whatever it is.
Yeah, I mean, you could do that. It makes the numbering a little bit weird when you get into the B extensions because then they start incrementing by 2. The code points increment by 2, even though the ID only increments by 1.
Oh, I see. Huh. I have to think about that, but that's just presentation. So of the 2 extensions we're actually proposing, what kind are each of them?
So right now, I think we only actually have 1 proposed extension, not including the padding and the frame marking extension, which is Dread. So Dread would be a long extension.
Mm-hmm.
I guess technically we also have the reserve for future use extension, which is also a long extension.
Yeah.
I think one of the primary use cases of the short extensions would be this enhancement stuff when it starts using side information, but currently it doesn't send any side information.
But you would expect those to be short?
I would expect them to be short, but like I don't think we've actually designed how that works yet, so I don't know that that's how that will work. And one of the things that I kind of wanted some feedback on for the design was, once we've sorted out a bit more how that will actually work, like, make sure that it makes sense to be doing what we're doing with the short extensions in that context.
Yeah, I mean, I'm a little reluctant to just find all this mechanism before we know whether we're actually going to, what our extensions, what anything other than our one extension is going to look like.
Right,
That
I
that's
agree.
Yeah, I think Jonathan is echoing something I said on the list too, is that in this design, it would greatly inform the design if we knew what the properties of the actual extensions were. So my first question was, do we know of any extension that will have no data other than the separator?
Right. So
Does anyone plan an extension that has no data?
So I can give one example that I thought of anyway, which is you could have an extension to just disable the enhancement on a per frame basis. And there's a bunch of reasons why that might not actually make sense, right? Because to do that means you need to run the thing on the encoder to see whether or not it's doing a good job, and you need a metric that tells you whether or not it's doing a good job. And if you shut it off for one frame, like there'll be some crossfading. If you turn it back on the next frame, there's more crossfading. So there's a bunch of reasons why you might not actually do that, but that's sort of an obvious case of, here's a knob that you might want to have that would require no data other than, 1 bit shut it off.
Okay, so if we do expect some more extensions that have no data and just serve as a flag, then we do need multiple code points for those. I put a counter, I didn't see this proposal before I put my proposal on the list, but it was basically to flatten out the space and just enumerate all the 256 code points. And the INA registry would just list literally all the 256 code points, and we'd have, only 4 or 5 of them registered at, at the close of these 3 drafts. And then more extensions could come along, but basically you'd have reserved code points for 0, 1, 2, and 3, and maybe 4 byte, or whatever we think the right number is for these short extensions. Have a handful, 32, 64, whatever code points for each of those sizes. And then a bucket for the variable length ones that encode their own length byte or go to the end of the packet.
Right. And to be clear, like I'm not proposing like this is the design, right? Like this is just a straw man I put up to get some discussion going. So I did see your proposal on the list. And I think one of the things that I tried to do here that, your proposal didn't do was this grouping in the B extensions to make sure that you have, both representations available for every extension, right? So you can do the splitting and merging of extensions. But on the short extension side, I agree with you. Like there's, there's tons of ways that you could splice and dice those extensions and decide on what lengths you might have. I did talk briefly about this with my co-author. We sort of looked at, like if you want to encode an extension of length 4, and it's your only extension, right now it would take 7 bytes, right? Like, the overhead of switching to a code 3 packet, you have the overhead of specifying that padding is encoding the padding length, you have the overhead of signaling the extension ID, and then you have your 4 byte payload. Whereas, if you just used a long extension for that, it would be 8 bytes. And so is the difference between 7 and 8 bytes long enough to reserve a bunch of short extension IDs? I don't know. It didn't seem to be that important to me, but maybe it makes a difference if we expect to have a bunch of extensions in every packet.
I guess like a thing to keep in mind is that a byte per packet with 20 millisecond frames is 400 bits a second, which is large in the context of some use cases. So
Yeah, that's about a quarter of the current dread. So actually, that's a good question. Is what is the current size of the current extensions for dread? What is the typical size? Is it variable, or is it reasonably constrained to just 3, 4, 5 bytes?
So I think it supports anywhere between 10 kilobits and 100 kilobits. So you can divide that by 400 to get bytes, right? So somewhere between 25 and more bytes.
So it's already in the variable length category. It would never benefit from the short encodings. So what do we have any extensions planned that benefit from the short encodings from 2, 3, 4, 5 bytes, 0, 1, 2, 3, 4 bytes?
Yeah, so I would hope the enhancement stuff would, just because if you start using enough bits that it wouldn't benefit, that it would need one of these longer encodings, you know, that's an awful lot of bit rate that you could have just been using to code at a higher quality. But maybe Jan has more opinions on that. I'm personally just guessing at the moment.
Go ahead, Jan.
Yes, hi. I tend to agree, so I think...
Hold on a second. Something
so
with your audio sounds very robotic and very loud. Try it again.
Okay.
Still very robotic.
I can try to switch my audio 1 second. How about now? Better? Better or not?
Yeah, I'm sorry, but it sounds very robotic and almost like slow motion too.
Really? Oh, that's worrying. I have to figure this out.
Is it possible to type into the chat what you wanted to say? And we'll relay it. Or give it a shot and let's see if it's audible.
Yes.
It's awkward, but let's see what.
Yes, I mean, I have to figure it out anyway. But I tend to agree. So I think enhancement is a very promising candidate for having just 1, 2, or 3 bytes. Given the fact that you have these very low bits.
So even the transcription didn't quite get, unless you were talking about grade 6. I don't think we heard you right.
Oh,
I'm not sure what corpus this transcription was trained on, but talking about grade 6. Oh boy. Yeah, just type it out if you don't mind, Jan.
Okay.
he said he doesn't.
Okay, the enhancement will use a few bytes. Hey, can you clarify, is that 0, 1, 2, or 3? Or could be any of them? Okay. So we do have a valid use case for 0, 1, 2, or 3, and clearly variable. So I think we probably should try to figure out a scheme that does divide the space in order to make the short extensions efficient without another length encoding. So I'd encourage people to please review Tim's proposal and also the other proposal that I put on the list. And if anyone has an extension that they plan to bring, please mention what the expected data size is for that extension. That would help inform this code point allocation. Okay, Tim, you're back.
All right. If there are no more questions, I think that was everything for this slide. And so basically, alluding to the question I think that's already been raised, when should we actually aim to go to working group last call for this? I think on the schedule we had it drawn up as in at the end of last year, which obviously didn't happen. I think it would benefit from being able to see one of these, enhancement with side information, things get a little bit more well developed, just so we can make sure that the design works with that. But on the other hand, if Dread winds up being ready to publish before that, like we don't want to hold up Dread waiting for this draft to be published. So trying to gauge what people's opinions are.
So let me ask a show of hands of how many people have had a chance to read this draft? And if you're online, maybe just +1 in the chat if you've had a chance to review this draft. Okay, so I'm only seeing 1 or 2 in the room, 3 including myself. So I think we need more reviews. And I see 1 online. 4 reviews is not terrible, but 5, okay. That's a decent number, but I think it would be useful to have a few more eyes on this. I'm not confident that we have all of the major issues sorted. I'm not confident that the STP negotiation section is well understood by everyone and what the nuances of whether you're able to negotiate all of these individual extension IDs, whether they're symmetric or whether they're receive only or send only. All those nuances in the STP offer answer model, I'm not sure are captured properly in the current version. So please review this with the lens of everything that you think could impact interoperability. And that would include at least the STP section and at least this extension ID numbering, but I'm sure there's other aspects in the doc too. So I'm reluctant to try to go to work group last call until we have a few more reviews and some more feedback on the list on this.
Yeah,
Anyone
I think
feel
that makes
differently?
sense.
I see Jean Marc has his hand up.
Go ahead, Joe Mark.
Yeah, just a comment on the timing. I think it's, there's this trade-off of, obviously we don't want to delay Dread, but if we wait longer to see what extensions we have out there, maybe we get to make better decisions. So I think what maybe would be a compromise in there is to make sure that at least what we use right now for Dread, which is basically the set that we reserve for the long extensions, if we sort of agree, at least unofficially, that we're not going to change that, then it means we can start, shipping experiments with Dread, having tests that run in the wild, and make sure that when we finalize the extension, we don't like randomly shuffle the code points and have everything break. Like, as long as the as long as the final draft maps, 0 and 1 IDs and the experimental IDs in the same place and the 127, we're pretty good, even if it takes some time for the extension drafts to be finalized. I don't know if that makes sense.
Yeah, that makes sense. And when you say experiment, do you mean just a developer experimenting on their own, or do you mean an actual deployed experiment? Like actually putting it in WebRTC experiment or something on a Chromium flag?
Yeah, I mean that kind of thing, like being able to have it in a flag, or have like some applications start using it with this, using these experimental code points. Like it's not going to break anything unless we decide suddenly to reassign these experimental things with like something actually useful. Then, these things might break a bunch of things. But otherwise, if there's a few things that we're using in experiments right now that don't move, then nothing bad will really happen.
And this is equally an argument to push to get the draft finished sooner rather than later as well, which also has a side effect of increasing confidence that whatever properties of it that need to be maintained for dredge are still maintained through.
Yeah, there's definitely a trade-off there. And if anyone can think of like wild ideas of what they think could end up being an extension, like even like posting a bunch of those on the list could help figure out if there's good or bad ideas, but at least like to see if there's a pattern of what would be useful, because we only have plans for like 3 or 4 and we're allocating for like 100. So clearly this is forward thinking, but it's hard.
So let's shoot for trying to get more reviews in the next few weeks, or certainly before the next meeting on this. And let's try to close off on the extension ID numbering first. And that will help stabilize the deployments. But we don't necessarily need to go to work group last call for the other aspects yet. Okay, Jean-Marc, you can stay on. Tim, are you done?
Yep, that was my last slide.
And just to clarify, the straw man that Tim is proposing wouldn't actually break anything in practice. Some of the SDP might change slightly, but if experiments get deployed like that, nothing breaks. So I am Jean-Marc Valin, and I'm presenting deep redundancy for the Opus codec. Next slide, please. So just a brief recap. DREAD, the idea behind DREAD is to code a large amount of redundant audio in every Opus packet. We use a DNN to maximize the compression, and that allows us to code up to about 1 second of audio in each 20 millisecond packet, so about 50x redundancy, with bit rates that range from about 10 to 100 kilobits per second of overhead for the redundancy. Next slide, please. So changes since the last meeting, there's been mostly 2 changes, and they have to do with the signaling. The first change is we added an extended offset field. So it's an optional byte that we can add to the packet, and that can signal offsets up to about 20 seconds. We don't really need up to 20 seconds, but that's what an extra byte gives you. Without the extended offset, the offset can be plus or minus about 40 milliseconds. So it basically says how is the redundancy aligned with the packet you are receiving. And being able to signal much larger offsets has a few uses. The main one for which we added that is to be able to trim silence. So if you have a stream and the person just stops speaking, you don't need to actually encode all of the silence. You can just say, well, there's an offset, and then it starts in the past. This allows for more efficient use of the bits, but it is also helpful for the case of DTX. This is how we discovered the issue. If your jitter buffer doesn't know about silence, then you may be in a situation where you receive the first packet after DTX, and the jitter buffer goes, "Oh, I missed so many packets because they didn't arrive," and then try to fill in the buffer with silence and add delay and so on. So adding that extended offset fixes that. It would still be nice to fix jitter buffers, but seems like it's useful. And another use for it, it's a bit more far-fetched, but it's something that we've discussed previously around SFUs. So if an SFU just just switched to a new stream, it could keep the dread from a previous stream, the previous active stream, and just keep incrementing the offset for some time until it decides to switch the redundancy to the new speaker. I don't know that anyone would really use that, but it would be out there. And that use case is the reason why the extended offset is 1 whole byte, so it makes it much easier to insert. So that's one of the, oh, sorry.
One quick question about your SFU use case and for these changes.
Yep.
SFUs typically, the ones that don't decode the media, typically rely on audio levels and a header extension to make their forwarding decisions, their switching decisions. Should we have any guidance about these extensions don't contribute at all to the audio levels, or do they?
I don't think they contribute to the audio level. It is just about containing information about previous packets, but if you don't lose any packet, you're never going to use any of these extensions. Oh, you mean if you lose a bunch of packets, theoretically, you could get the levels from that, but that seems a bit complicated.
It may be useful to have some text about how this interacts with audio levels that SFUs use to make their switching decisions.
In general, it wouldn't unless you actually choose to try and do something funny with it.
It may still be good to have advice on it.
Okay, I would need more clarification about what exactly that advice would be. I see Tim in the queue.
Yeah, I maybe Mo can correct me if I'm wrong, but I think the issue is, you know, the packet might contain a bunch of useful information about past stuff that had high audio levels, but if the current frame has no audio levels, then the SFU will never forward it.
Yeah, I would need to understand a bit better how these things work, I guess, to to say something useful. My assumption there was mostly that, you know, the SFU would forward speaker A for some time, and then at some point decide, you know, now I'm going to forward speaker B. And the only thing that this would change is when you just switch to speaker A, you might want to include the redundancy from speaker B, because that would be more useful if you want to just forward something.
Yeah, I think the audio levels question can even, you know, that question matters even with just a single speaker.
Yeah,
You know,
I mean, in that case,
if the
it
SFU
means
stops
you're,
forwarding during silence.
I mean, the SFU, what, sorry. Go ahead.
Please finish.
I was just gonna say, like, I think the SFU, it makes sense for the SFU not to forward silence, but at the same time, if it sees that there's dread, it might as well, it may decide to forward it, but I don't think there's gonna be much information in the dread packet to make that decision. Like if there is redundancy, then presumably if the encoder is not too dumb, then probably there is some non-silence in that redundancy. Like, you could have your encoder work in any way you like, but the way, for example, the current encoder will work is, you know, if the past second is all silent, it's just going to not encode any dread. So if there is dread, then probably there is some redundancy about some speech in the past.
So maybe it's useful to try to think about, can any of this be summarized for useful, you know, developer guidance, SFU developer guidance around whether these extensions, you know, impact SFU switching, or decisions about what the audio levels apply to, whether the extensions are relevant or not for audio levels. a little bit of text, a little bit of thought about whether text needs to go in to clarify those things, because I think from the discussion, it's not clear to everyone what should happen.
Yeah,
Yeah,
I can try adding some information there. But
Yeah, I
go
think
ahead.
even adding what you just said of, if you see dread, maybe you should forward it is would be useful guidance.
Although even then, like if the encoder decides to use dread all the time, even for silence, then you might be aware of that. But I can also say that if it helps. Okay, should I switch to the next change? Oh, Jonathan.
I mean, we should say encoders should not encode dread of silence.
That is a fair thing to say, yes.
And also there was a question on the chat about what happens if you're putting the history and there's more than one silence period. Can you have multiple dreads in a single packet to cover different time periods?
No, right now it's a limitation that we can we encode backwards, so we can skip the last silence and then we have some speech, and we can skip the earliest silence, but if there's speech, silence, speech, then we will have that gap. And there's
You couldn't put two different dread extensions in the same opus packet?
theoretically, yes. In practice, it would be a nightmare.
Okay.
Like I think from an implementation point of view, I looked at that. Like you could also have like a mask of some sort,
Yeah,
but all
so
the things
maybe
I could think of
it's
end
probably
up
worth
being
saying
quite
what to do.
complicated.
If it's not supported, you should probably say, if you receive this, ignore all but one, or throw all the extensions away or something, because something weird is going on. Something you don't understand is happening here.
Oh, you mean if you actually receive two dreads in a packet?
Yeah.
I think we say something about that in the general extensions draft, or we don't, in which case dread will need to say only one is valid. Yeah, okay. Okay, so next change. Oh, Tim, did you want to add something?
Yeah, the general extensions draft says that all other extension drafts should tell whether or not they're allowed the thing to be specified multiple times.
Okay, so dread will say then that only one extension is allowed per packet or per frame. I don't know that multiple per frame makes sense, but we can discuss that.
It just says per frame, I believe.
Okay. Okay, so the other change was suggested by Tim, and it's basically adding a Qmax field. Basically, we have a Q0, which sets the highest quality quantizer for the most recent speech. We have a DQ parameter that says how much the quantizer will sort of degrade as we go back in time. And Qmax basically sets a cap on that. So, for example, you could start at quantizer 5, and increasing quantizer number is worse quality, lower bit rate. So you could start at 5, and then it degrades, it goes down to maybe 10, but you say never go worse than 10. Otherwise, by default, it will go all the way to 15 if you have enough frames. So it's just more general. It's not used right now. And the cost is only 1 bit to say, Qmax is just the default of 15. So that's how it's used basically. And it's a variable size as well. So, if you start at 15, if you start at 10, then there's no point in signaling that your Qmax is 9 or 5 because it can only increase. Next slide, please. So this is what the current format looks like. So we start with those Q0 and DQ, and then the X flag just says whether there is an extended offset. So with that, we have an entire byte. The extended offset is 1 byte that is optional. As I said, the reason we make it 1 full byte, even though we may not need 20 seconds of offset, is just because 20 seconds or sorry, actually, yeah. Yeah, so basically it makes it easy to insert the offset if you have some middle box that wants to change that. The rest of the offset is 5 bits Q max that is there. I don't know how to show that, but it's actually variable length. And then we have the rest of the dread that we discussed earlier with the initial state and all the latent vectors. So next slide, please. So in terms of how we actually standardize that, the current proposal is to standardize the part that turns the on the wire bits into the vocoder features and standardize only that. So that would mean that all of the DNN weights for the decoder would be frozen. And I propose to publish that using a simple binary format, ideally just the simple format that we use right now in libopus, just because it would ensure that it's better tested, but it's a trivial format to interpret. After that, we would define sort of these acoustic features. They could be defined in 2 different ways. Either we define the actual processing that gives us these features, or we define them from the vocoder point of view. We can discuss that further. I would tend to prefer probably defining most of them as just the actual processing you apply to the audio. The only slightly tricky one is the pitch, which is currently specified using a neural pitch estimator. So either we find like a good enough definition of the pitch that makes it possible to use different estimators eventually that get better. I think that would be preferred if possible. Otherwise, we could also just specify the weights of the neural pitch estimator. It is not very big, but maybe it can be improved also in the future.
Question about that. How many weights and what fidelity, what size? How much are we talking about publishing?
For the neural pitch estimator, I think we're talking about tens of kilobytes, if not like 100 or 200 kilobytes max. I would need to check the exact numbers, but it's definitely smaller than much smaller than the decoder.
What's the decoder size, decoder weights?
Decoder weight is, yeah, good question. That is about a million parameters, and they're almost entirely quantized to 8 bits. So essentially in the order of a megabyte.
And how are you proposing to publish this? It's a normative aspect of this document. You plan on actually publishing in this document?
I don't think it makes much sense to actually put that in the RFC. I think we probably want to find something that looks a bit more like what we did with the test vectors.
But this is normative. It's not just a test vector.
Yeah, that one, yeah, we would need to find something. I mean, we could obviously have like the SHA one or something and have it in different places.
Be thinking
Encoding that as base 64 is, some people are not going to like the resulting RFC, to say the least.
Keep that in mind.
Yeah, but we will need to find a way of publishing about a megabyte. I'm still trying to shrink that down a little bit less. I actually maybe I managed to get it down to about 700 kilobytes. Maybe we get to 500 kilobytes, but it's not going to be 100 kilobyte. That I can pretty much guarantee. Not without losing a lot of quality. Let me see, where were we? So yeah, so the encoder would be left unspecified. And the idea, again, on the vocoder is to have really minimal constraints just to define what its features should be and to say, it needs to generate meaningful speech out of that. Next slide, please. So in terms of implementation, all of the changes that I mentioned are landed in the Opus main branch. It used to be Opus NG, now it's called main, it's the default branch, everything is there. It was also, all of that was also released as Opus 1.5 2 weeks ago. There's a link to a demo that demonstrates all of these features. In that release, Dread, as well as the enhancement, everything that is not standardized is disabled by default. It needs both a compile flag and a runtime flag to enable. And for those who would like to play with it, there's actually a WebRTC patch that adds Dread support. And we've started testing things with that. It seems to work. That's how we discovered that probably this extended offset would be useful for DTX support. But I would encourage everyone to try it out and see for themselves and report any bugs. This is how we improve this.
Question on the WebRTC support. Are you asking anyone in the community to try to upstream this anytime soon, or you want to wait until it's more mature and settled before you want in the wild experiments in WebRTC with it?
I believe considering that these things are off by default, like I think those should be. It should be safe to talk about upstreaming this. Maybe there's a few bugs and we want to iron them out, but I think we're at the point where it starts making sense to do that.
Have you spoken with anyone about upstreaming it? I see Harold in the room, but I don't know if he's interested to upstream any of this yet.
We're starting to. Oh, there you go.
Just saying that I'm punting that question. I have to ask other people.
But yes, I've started speaking to some people about trying it, deploying an experiment and so on. We'll see how that goes. Takes some time. Jonathan?
Does this patch not only turn it on, but also wire it into the jitter buffer to, and how far back can you recover? Because, obviously there's trade-offs between length of or delay from jitter buffer versus how far back you can do recovery.
Basically what it does, and I did not write that patch, Michael Quingbile did, but my understanding of the patch is that essentially it leverages what is already existing in the WebRTC stack, which is if your router just decided to hold on to a whole bunch of packets and release them all at the same time, the jitter buffer would suddenly go back, play that faster, and eventually catch up and adjust its delay according to that. So it essentially just turns the packet loss case into the case of my buffer just hoarded a bunch of packets and released them all at the same time. So I believe it's able to cope with at least half a second, maybe all the way to a second. I'm not sure exactly. Next slide, please. And so these are actual results we got with the WebRTC patches. So previously we had results that were just based on sort of theoretical infinite delay case, but this is WebRTC adjusting its delay according to the losses. And we used a loss simulator that is trained on real data losses, but they're still synthetically generated, but they're bursty. They're not just independent random loss. And we used PLC MOS, which is a Microsoft model to estimate the quality of PLC. So, you know, essentially blue line is what you get without any redundancy, falls apart pretty quickly. LBRR in orange, eventually it also falls apart. And green and red are with dread, either with or without LBRR in addition. So, you know, even at 90% loss, it still actually holds on. And, you know,
Clarification question, is LBRR just one frame back in this? Is it
yes,
one frame?
LBR only ever supports one frame.
And how many frames is Dread here?
Dread is configured with up to 1 second, but it'll adapt based on the bit rate. You know, depending on how many bits you give it in the encoder, it might encode a bit more, a bit less. But in this case, it's between half a second and 1 second.
Okay.
Next slide. So there's still a few open questions. These two are actually still from the last time because we didn't get so much feedback. The first one is, should we have a maximum duration allowed? Technically, with the current draft, you could actually encode up to about 10 minutes of redundancy in one packet. That is pretty much useless, but my current proposal is to not have a hard limit and just say the receiver can ignore whatever it doesn't want to deal with. So it's free to decode 1 second, and if the encoder encoded 10 minutes, then so be it. And the second one is, oh, Jonathan?
Yeah, Jonathan Lennox. I think I mentioned this last time, but we should, even if we technically allow that, we should probably have warnings that, you know, should not, unless you really think it's going to be useful, especially because it's problematic for the, you know, conferencing late joiner cases. You don't want somebody to be able to scrape out of the dread the conversation that happened for the 10 minutes before they joined the call.
That seems like a case where you would want the SDP to say, don't ever send me more than that. And that one was changed into a must.
Okay, so there is signaling in SDP, this is the most you should ever send me.
Yes.
Okay, yeah, that's useful.
But basically, that is a minor change we did to the draft, but it was like, please don't send more, and it got changed to definitely never send more. It got changed to a must.
All right. Yeah, in that case, it's probably fine as long as you maybe have like something in the draft reminding middle boxes that they want to set this parameter for security considerations. Yeah.
Okay. And another open question was, you know, lowest versus highest useful bit rates. Right now, what's in there is what seemed to me like it made sense. Lowest for 1 second, the lowest bit rate is about 10 kilobits per second, which is equivalent to 20 bits per second in terms of, you know, if it wasn't redundancy, if it was like a pure codec. And it goes all the way to 100 kilobits for 1 second, or 2 kilobits effective bit rate. Essentially, like ballpark, like less than 10 kilobits for 1 second becomes not really intelligible, and beyond 100 kilobits, it was hard to measure, at least with objective metrics, any improvement.
Okay, that's what I was going to ask. So, but basically, that's the range which you see, you know, from the bottom is intelligible and the top is diminishing returns. So,
Essentially, that's what it's designed to do. But I encourage people to try it out, and maybe they go
And
like,
again, does this need to be
actually, I would.
does this need to be something that's the standard says isn't allowed, or is this just a engineering recommendation to say, if you're implementing it, there might be things on like for the, the libopus API saying setting it below this value is not useful, but that's not the same thing as saying forbidding it in the standard.
No. It is related to these quantizers we signal.
Oh, I
The quantizers are fixed. We have Q0 all the way to Q15. Q0 will give you 100 kilobits per second for 1 second redundancy. And if you keep it at Q0 all the time, if you keep it at Q15 all the time, you will get about 10 kilobits per second for 1 second redundancy.
Oh, I see. So this is a matter
So
of.
these are really like kind of set in stone.
Okay. In that case, if you think this is the reasonable range, then I believe you.
I mean, that's what I believe. If you try out, then you go like, I'd like to support even lower bit rate or even higher because, there's a use case I didn't think of. I'm open to that.
Question
Go ahead.
about how this scales down to less than 1 second. If you only did 500 milliseconds, does this scale linearly down or logarithmically down? Or can you not go lower than 1 second?
Oh, you can definitely go lower. Essentially, you pay a fixed cost for including any redundancy. Like you have the the signaling, you have this initial state. So those you will code no matter how much redundancy. But after that, it is almost linear. Like if you set the constant Q, it would be linear. In practice, we tend to degrade the quality as you go further. So doubling the amount of redundancy doesn't quite double your bit rate, but it's not logarithmic or anything like that. One other open question that I forgot to put on these slides is, it's been mentioned a few times, is should we support truncation? Meaning, should we make it possible for a middle box to just decide, I don't want more than this many bytes of dread, and just discard the last bytes? It is possible to do that. The caveat is we would need to add one truncation bit, and when that bit would be set, if you discard a certain number of bytes, then I think there's like the last 3 bytes that you haven't discarded becomes pretty much useless. But they need to be kept just so that the entropy coder is in sync. So it's a bit wasteful, but it could be supported if someone thinks it's useful. And I say last 3 bytes, but we would need to check. Maybe it's 4. Tim would know the answer. I don't. Go ahead, Tim.
Yeah, I would need to double check also, but I thought it was 4. But I think also worth pointing out is that, most middle boxes are probably going to want to do some truncation based on a point in time, and you don't really have a mapping from time to bytes, other than essentially guessing.
No, this
At
would
least
only be in order to save space of some sort. Indeed, for time, it would be, you could guess, but you wouldn't get anything reliable.
Yep.
Go ahead, Jonathan.
Yeah, I would say don't do this now. And I think the way we would design the extensions, we could have a separate extension that is truncated dread rather than having a truncated bit in the dread. So if we want to do the truncation, add truncation in the future, you could presumably add it. That
Also fine with that.
Yeah.
I mean, if we think it's useful, it just costs 1 bit to do it now. But if there's doubts about whether it's ever useful, then we can just drop it and support it later. Next slide,
That's it.
or that may be it. Yeah. So that's it.
Okay, so we had asked previously on the list whether people had a chance to review this because we're hoping to do an adoption call soon on this. Jean-Marc, do you think it's ready at this point, or do you plan more significant changes that you think should be done before the work group takes this on?
I don't feel like there's any really major thing that's going to happen that would change how the working group views this. It's definitely not done, but I would assume that the final thing looks quite similar to how it's now.
Jonathan?
Does adopting it mean we have to have at least a temporary solution to the where we're putting the binary blobs? I mean, in the GitHub might be a fine answer, but
I don't think a solution is required before adoption, but a solution is definitely required for publication.
yeah,
But
but I feel like we need, if you have a draft that says, and here's the binary blob, we at least have to have somewhere that we can point at the binary blob. Maybe that's on the opus.org site, but we need to have somewhere we can at least point at that binary blob if we have a spec that references it.
yeah, I mean, I think it's an important issue. Maybe Murray has some, guidance about it, but I don't think it'll impact adoption.
Maybe it's normal for a draft to not be complete when it's
Yeah.
adopted, right? So.
I don't know if IETF has any kind of resource for normative big things.
Yeah, don't make more work for me just to go.
So the light is no longer the light is no longer am I leaving you guys? No, but I mean, eventually. Oh, in a year, sure. Yeah. I don't want to be done
Cullen?
Cullen Jenks, where is the blob right now? I mean,
On
So-
Jean-Marc's computer?
yeah. So
No.
I-
Right now, if you want to get the blob, you need to get the actual source code. The plan is to also add the links to the draft, but you get the source code, and there's a download that comes from a zip.org server because it doesn't fit in Git, obviously. But
I think we just
you
heard
download the
blob
source code.
Zip Hub, whatever. It's fine for right now. I don't see a problem. We'll start working on a better way to do it. We can.
Yeah, I mean, I don't expect to resolve that issue immediately. It's an issue that we need to definitely think about, but I don't see any problem adopting the draft before that issue is resolved.
Totally agree.
If anything, that would probably benefit from the work group actually working on that part and not the individual figuring that out on their own. So do a call, or do you think just wait?
Yeah, I think we can do a call.
Okay. So we'll ask to go ahead and do a quick poll here to see if people are ready to adopt this. Let me, Okay, so you should see in your client the adoption question. Do you think that this document, the current draft version, is a good starting point for our milestone on the Opus redundancy draft? Testing the tool? Okay, I think it's pretty clear consensus now. There's
Highest ratio of vote
infinite ratio.
14 responses out of 22 participants. It's even more impressive.
Okay, so it's clear that people feel we are ready to adopt this draft as work group item. So we'll confirm that on the list. But just for the notes, it was, 10 yeses to 0 nos and 2 no opinions in the room. And I didn't see what happened on the chat, but. So Jean-Marc, prepare to submit this as a work group draft. We'll just confirm for 2 weeks on the list, and then you can submit it.
Okay. Should I incorporate some of the changes that got discussed today before doing that, or should I upload the current version and then make the changes?
Feel free in the next week, if you have time in the next week or two, upload, make all the changes that we've discussed. And at the end of the adoption call, you can publish a new version under the work group with those changes.
Thanks.
Okay, Jan, you're up.
Oh, it works.
Okay, I hope you can hear me.
Perfectly.
Can you? Okay, great. Hi, my name is Jan Büter, and I will give a brief update on the speech coding enhancement draft. There is no update of the draft itself, but there are updates that are relevant for the specification. So just a quick recap. What I'm trying to do is there are basically 2 tracks. One is developing enhancement algorithms. The other one is standardizing it. And basically for the algorithm development, we want to get the best method that we can do with the knowledge we have now. But for standardization, we want to keep the door open for future improvements. That means we rather intend to standardize quality requirements instead of the method itself. Next slide, please. And this is where we are currently at. So there are 2 enhancement methods now that have been published in paper version. And what happened since last time is that these 2 methods are now actually integrated into Opus as part of the 1.5 release. And standardization is naturally lagging a bit behind. So what happened there so far was the evaluation of quality metrics from last time, and in particular, a modification of Opus Compare. The current Opus Compare tool seemed a good candidate, but if someone has still some feedback on that, I'd be interested in hearing it. Next slide, please. So the Opus 1.5 integration, what it actually means is there was a further size and complexity reduction compared to the published versions in the paper. Also, now the enhancement method is compatible with all the modes. Previously, it only worked for Silk. Now it also works for hybrid mode. Mode switching to CALD is supported. It does mono stereo, so everything is there. And it's also compatible with the neural packet loss concealment algorithm. I also included, for reference, a table of the general resource requirements. So complexity is now from 100 to 400 megaflops, and I dare say it requires reasonable to negligible amounts of overhead on typical WebRTC end devices. But if somebody has a different opinion, I'd like to hear it. And in particular, what this means is it's the first complete implementation of an enhancement method or enhancement methods inside Opus, fully integrated, and this is of course a prerequisite for continuing with the internet draft. Next slide, please.
One quick clarification on the compatibility modes. Is it actually improving anything beyond just Silk, or it's just compatible with the Kelton hybrid modes?
It's also improving hybrid mode because Silk is the low band for hybrid mode. Surely not optimal yet, but it's improving. For CALD, it's doing nothing, but it's not making things worse when you switch back and forth. And in Silk, it's actually, it also runs for stereo on both channels, and that I tried a few examples, and that even improves stereo quality. Yeah, that's what it does. Okay, then next slide, please. I think this is a good point to raise some questions about signal in general. I mean, Jonathan has a question.
Yeah, sorry, I had a question on the previous slide. So when you're using it in hybrid mode, is the celt component done all over the, how does is the celt component added to the part that's had this processing done, or is it added, how does that work?
Yes.
Yeah.
I mean, you basically have the Silk output that's processed and enhanced, and then you add the celt hybrid.
And on the
top of
encode
that.
side, I guess there's no difference on the encode. There's no difference on the encode. The encode side is not unchanged, right? This is just.
It's unchanged, yes.
Okay.
For now, it's unchanged. Yeah. So, I mean, these are at the moment still blind enhancement methods, so they don't need any side info. But I mean, with the situation now, there are already 2 enhancement methods out, and there might be more in the future. There might be different versions of methods. So the question is, should there be some signaling? Do we need a naming scheme for even identifying and communicating methods and versions? Should the decoder disclose what methods it will use? Should the encoder have the power to disable or forbid using specific methods? So these are questions I'd be very interested in getting feedback now or later.
Jonathan, did you mean to be in queue? Are you?
Okay, then later in this case. Yes, then next slide, please. So the next steps on the algorithm development side, that would be improving speech coding also for bandwidth higher than wideband. It's done now indirectly because of the hybrid mode, but it's surely not optimal. And there's more to be done. And for standardization, the next step would be to really take now this full implementation and the pre-study on quality metrics and turn this into a first proposal. What requirements to ask from an enhancement method such that it would be permitted by the specification. Yeah, and that's it. Next slide, I think there's a thank you coming up. Yeah, thank you.
Any other questions about speech enhancement? So just real quickly, I'd like to back up onto the standardization question. You're currently proposing 2 different enhancements, right? Linear and nonlinear, and you plan,
yes,
if we want these signaled, they would be 2 independent extensions that would be signaled, and they're flags, right? They don't carry any data.
I don't think it should necessarily be signaled in band, but it would be rather be like an SDP thing. But this is kind of the question. I mean, but Jean-Marc has an opinion about this, I believe.
Yeah, I think the main idea there is that we don't specify these techniques. Like Jan has 2, maybe someone else comes up with different ones, and the idea is any decoder can turn on its enhancement and get better speech quality. And the idea of what we're standardizing is just making sure that how to say that an enhancement is compliant, like ensuring that it's not going to make things worse. So if it meets these criteria, the decoder can enable it with no signaling, no nothing. signaling would be optional if you really want to say something in particular, but normally the encoder sends it. For example, you could have a 1.0 encoder and the receiver has the enhancement, so it just gives you the better speech, and that's it.
I guess my question is, if you're encoding something that very much isn't speech, I mean, I guess presumably you would be using a pure, you'd probably be encoding as pure kelp in that case anyway, so maybe it doesn't matter, but I'm worried about, like, I don't know, have you tested what this does to things that are not speech, if there's silk in the mix, like song or, you know, percussion or something like that?
Not so much yet. It would be an interesting thing, and I mean, monophonic instruments would probably be a good candidate. So I think in this case, you sometimes get speech coding.
Yeah,
I will put that on the list. Yeah, that's definitely something to try out.
Yeah, and I think that's,
I think it's a good point that we just don't want it to fall apart. Like you
Yeah,
won't
but I
expect it to enhance, but you don't want it to explode.
yeah, but I mean, maybe you'd say, hey, this is something that's, we're using, we have some silk encoding here, but it's not speech, so turn off any speech enhancements flag. And I think that would have to be in band, not in SDP, because this is something that could change over time. It also change if you're in a multi-party conference for different audio streams. So I think something that's in band in the audio would be necessary rather than putting it just in SDP. Period.
Thanks.
So one final question on what we mean by speech and what was tested, what the model was developed with. Is it only trained on single speaker, near field mic only speech? Is that the?
Yes, basically. It's a clean speech data set, multilingual, but that's basically what it does.
But it's never seen signals from far field speech or multiple talkers or background talkers?
No, it hasn't. But I mean, the same is true for vocoders, like what's used for Neural PLC. So it's been tested on that kind of speech. It's also been tested on real recordings, and it generalizes well. So from what I've seen so far.
Okay.
I mean, even in the last study, there was noisy speech, for instance, that has also background talkers and so on and so on. So far that worked, but it's definitely something that you want in your testing material.
So I think no more questions on speech coding.
Tim is in the queue.
Thank you, Jan. Tim, go ahead.
Yeah, I just wanted to say that the in-band flag you were talking about to turn off the enhancements, if the use case is for content that isn't speech, that isn't really specific to any one algorithm, right? So that means we don't need to worry about the naming and the versioning and that kind of thing. It's just a matter of, do you do this or do you not do this? But if there's another use case where, you want to be able to disable something because, somebody's deployed some model and it's gotten really popular and shipped to a bunch of devices, and it turns out it has some, horrible problem, then, maybe you want some kind of, ability to turn that off. But if that's not your use case, then these have different solutions.
Good point. Okay, if no other questions, thank you very much, Jan. And that's the last presentation.
Yeah, thanks.
Any other business that people wanted to bring up in this meeting? Nope. Okay, so we'll confirm the adoption call for the dread draft on the list. We'll set it for 2 weeks.
2 weeks.
And please review the current version of the extension mechanism and highlight any issues before we try to progress it to work group last call.
Thank you, everyone.
Thanks.